In this lesson, we're going to be discussing systems of equations, solving them by using the substitution method. The process for solving the systems of equations by substitution. First thing you want to do is if one of the equations is not already set equal to one of the variables, you want to set one of the equations equal to either x or y or one of the variables. And then you're going to substitute what that variable equals into the other equation for that variable. Now this method is the most useful whenever one of the equations is already set equal to a variable. Alright, in this example, both equations are already set equal to y, so we can plug in 4x plus 1 in for the y in the second equation. We get 4x plus 1 equals negative 2x plus 1. Add 2x to both sides. We get 6x plus 1 equals 1, and then subtract 1 from both sides. We get 6x equals 0. Divide both sides by 6. X equals 0. And then to find the y, we just plug that value for x into either one of the equations. I chose the first equation. Replace the x in the first equation with its value, 0. 4 times 0 is 0, so y equals 1. So our solution is 0, 1. That is the point where the two lines intersect. Next equation, we don't have either equation set equal to a variable, but we can easily set the second equation equal to either x or y. So I'm going to subtract x from both sides. That'll give me y equals negative x minus 13. So now I can replace the y in the first equation with negative x minus 13. That'll look like this. Distribute the 2. Combine the like terms on the left side. Add 26 to both sides. And then divide both sides by negative 7. And for x, we get negative 6. Again, to solve for the y, we're just going to replace the x in that first equation, the y equals negative x minus 13. We're going to replace the x with its value, negative 6. Negative 6 is positive 6. Minus 13 is negative 7. So our solution is the point negative 6, negative 7. That is the coordinate where the two lines intersect. Next example, it would be easiest to set the first equation equal to either x or y. So I'm going to set it equal to y by subtracting x from both sides. Give me y equals negative x plus 6, and now I'm going to plug in negative x plus 6 in for y in the second equation. That'll look like this. Distribute the negative 3. Combine the like terms on the left side. When I combine the like terms on the left side, I get negative 18 equals 1, which negative 18 does not equal 1. So there's no solution for this system. Both of these lines have the same slope, so they are parallel and will never intersect. And for the last example, we want to set one of the equations equal to one of the variables. So I'm going to take the first equation, I'm going to set it equal to y. Alright, I'm going to start by subtracting 6x from both sides, and then divide both sides by 10. That'll give me y equals negative 3 over 5x minus 17 over 5. I'm going to plug that in for the y in the second equation, and then I'm going to distribute the negative 5. Combine the like terms on the left side. Now I get 17 equals 17. Let me back up and correct that. Put that 1 in there. Left out. Back up. Alright, so 17 does equal 17. So that lets us know that there are an infinite number of solutions. Both of these lines are right on top of each other, so they have all points in common.